Here live. As I mentioned, we are going to be releasing the recordings. We've got quite a few people who had asked for that as a follow-up. So the topic today, we're going to be talking about securing utilities and critical infrastructure in 2021. And we've got a very diverse panel. And I think one of the key things that we'll be focused on is actually what is critical infrastructure, what's considered critical infrastructure, because it's a little bit surprising. It's not just the power plants and the water treatment facilities, although certainly those are, what appear in movies and certainly headlines recently. But it's also what are the other underpinnings that make our world go round, both in terms of the economy, in terms of just basic services that we take for granted. So my name is Ian L. Patterson. I'm CEO at Plurilock. We're an identity-centric cybersecurity company, and we use artificial intelligence and human behavior as an easier form of authentication. And so our lens is really very much on the human. We focus on protecting workforces, so people within businesses, utilities, financial institutions. And so our viewpoint, particularly for this conversation, is going to be much more around the human element. But certainly, I always say that cybersecurity is a team sport. And so we have to partner with folks like Mohammad and Ian in order to provide really security for the totality of an institution. So with that, I'm going to pass it over to my evil twin, Ian Patterson, for an introduction on himself.
It's still open to debate which one of us is the evil one. I grew the COVID beard, but he used to have the beard before. So I think he is the original evil one. Yes, I am Ian Patterson, CEO of Cycura. It is weird that we both have the same name. It has haunted us since the day we met, but it's a fun thing. So Cycura, we are a Toronto-based cybersecurity company. We specialize mostly in offensive security, particularly around technical assessment work. So we do a lot of really high-end pen testing of everything: applications, mobile apps, web apps, APIs, infrastructure, hardware, sometimes, you name it. We're very good at breaking it, telling you where it's broken, and then giving you recommendations around how to fix it in a technology agnostic way. We do stuff like red team assessments for companies that are mature enough to consume that. We do source code analysis and review for somebody who wants us to rip down their source code and find the bugs. Our way of thinking about security is very proactive and preventative. So get out in front of where the problems are, identify where the real technical bugs that will burn you exist, and then you can start to build a roadmap to defend your organization, defend your application, whatever it is that you're looking to protect. And that's where a lot of the solutions like Plurilock, like Armis come in place. You can make an informed decision around the roadmap going forward. My background, I've been doing cybersecurity for about 20 years. I've worked in banking, healthcare, government organizations. So I like to think that I'm still a practitioner, even though I'm running this consulting firm now. So I will pass it over to my esteemed colleague, Mohammad Waqas.
Thank you. Yeah, just a quick note on that. I had the beard before even COVID, so I went up to there. Hey guys, I'm Mohammad Waqas here. I'm a global solutions architect for Armis. We are an agentless device security platform. So going into, vertical agnostic, going into healthcare environments, ICS, OT, critical infrastructure, utilities environments, and really shedding light on what exists on their network, talking about asset discovery, asset enumeration, and then the risk analysis on all the different specialized critical devices that you can't install agents on, right? So think of your medical devices, your robotic arms, your PLCs, HMI systems, and all that, which I'll be talking about some of the findings here during today's talk. So thanks so much for joining. Appreciate your time.
Well, as I said, I'm excited to talk about this. I mean, maybe just to kick it off, I think critical infrastructure, when you say the word, people think about power plants. I mean, for Ian and Mo, I mean, you guys are both in it, working with clients in different industries. What is critical infrastructure from your perspective?
Yeah, I'll jump in first. For sure, power plant, utility, water purification, those types of systems, they all make sense. Without them, we live in the dark and we live in the cold. We don't have clean water. So those are certainly at the top of the list. But when you think of critical infrastructure, you have to think about the other components that we depend on day to day. So I would posit some things that most people might not consider. We recently worked with a client of ours, a university that experienced a cyber attack, and they would fall into this category of critical infrastructure, especially right now, because they are leading a lot of research around biomedical and COVID and vaccines, and doing modeling for what infection rates could look like and things like that. And if they're not able to operate right now, they are part of the overall Canadian supply chain for medical information and how we get ourselves out of this pandemic safely. So critical infrastructure right now could include things like educational facilities, higher ed, that have research components to them. And then those institutions tend to have a lot of the things and systems in place that we think about when we think about critical infrastructure anyways, which is usually OT systems, operational technology, Scada systems, depending on how they're monitoring and controlling that OT. The IoT that Mo will talk a lot about, I'm sure, the industrial Internet of Things, connected sensors and stuff like that. And this incident that we helped respond to actually did very much impact some of those components and systems in that organization, including like lighting systems where they just couldn't turn the lights on in certain buildings because they had to isolate those systems. So that's one example that most people might not think of when they think critical infrastructure. And then another one I would bring up, an environment that both Mo and I worked in extensively is hospitals, which makes sense, obviously, right? Somebody gets sick, they have to go to the hospital. Right now, the hospitals are mission critical for the country. And unfortunately, during this COVID period, we've seen significant attacks against hospitals because attackers know that they can cause pain. We're seeing a lot of mostly ransomware attacks against hospitals because it's easier to attack the human and deploy a phishing campaign and get somebody to click on a link and get in that way. And then we're also seeing legacy remote access systems being compromised, and that's your foothold into the network, and hospitals tend to be pretty flat networks. But inside those hospitals, again, like the universities, there are a ton of interesting OT systems, like air handlers, for example, that filter all the air in the building to make sure that it's purified to a certain degree that's required for open heart surgery and things like that. If those systems are not working, you are not doing surgery that day and people are dying. And then you get into the massive boilers that run, the hot water through the facility. And again, if that is not functioning, you are not able to run the hospital effectively. And those systems are generally controlled through some sort of OT system. Some of it's legacy 2-wire, but then it comes back to a control surface somewhere, centralized machine that manages it. But what we are seeing now is more modernization of those systems, and a convergence between our traditional IT networks and those OT networks. And I'll pass it off to Mo and let him share some other examples and give some thoughts too on that convergence.
Yeah, absolutely. One of the when we're talking critical infrastructure that I like to focus on specifically is the transportation sector and grid. Tons of things that comprise of that, whether we're talking airports or even like highway systems, traffic lights, and so on. All of these things that are becoming smarter. And when you're talking about things like electric vehicles, right now you have connected vehicles that are hitting the road and so on. So really bringing that impact directly to a driver, right? There were some studies done where somebody was able to hack the braking system of an electric vehicle just by plugging into the actual diagnostics. But then if we look at infrastructure, especially something like today, where if we look at hospitals as an example, right, there's just so many different critical aspects of an airport that can impact society as a whole, right? So I like to view airports and airline industry and whatnot as almost a glue for globalization, right? That is what's connecting all these different pieces of the world together. That is what's led us to where we are today in terms of technology, in terms of interconnectedness and things like that. If we look at, transportation, if something were to happen, lights all turn green or they all turn red, right? Live free or die hard. This was one of the things, part of the fire sale. Let's be honest, I really like that movie. But yeah, it's not only about, hey, I can't get downtown, hey, I can't get to work, or my Uber is going to be 15 minutes late. It's literally the breakdown of critical services like police services, ambulances, fire trucks, right? And that just leads to the huge increase in crimes or even fatalities or injuries to civilians and so on. Now, one of the things with, let's just take an airplane as an example, right? Again, we're getting smarter at all these things, the infotainment system. So now you have USBs you can plug in to charge. You have the movies and whatnot being delivered by a wireless system. And what happened, I think this was like 3 or 4 years ago, was an individual was able to actually hack into the infotainment system and start messing with some of the cockpit readings, to the point that the US actually released a notice and a report saying, hey, by the way, be careful because you can actually impact the operations of an airplane directly by linking in through those infotainment systems and onboard entertainment systems. But then if we look at the airport as a whole, there are just so many different components to it. And one thing that Ian and we were talking about is that when it comes to these aspects, when it comes to the critical infrastructure, the top of mind thing is safety. So even if one small component gets compromised and that safety becomes, as opposed to 100%, it drops down to, let's say, 95%, 90%, at that point, you're thinking about taking things offline to preserve that the safety of all the other individuals and whatnot. And then the other aspect is, when we're looking at something that's impacted recently, is the Evergreen container ship, right? And the Suez Canal. So just by one single ship blocking that entire canal, you're looking at approximately, I think that day was about 30 or so ships that were just waiting in line and impacting 12% of the global market. To give you an idea on how just one aspect of transportation impacting the entire globe on that large scale, causing oil prices to climb and things like that. So really, I like talking a lot about the transportation aspect when we're talking about critical infrastructure.
I think the other thing too, especially with airplanes, is that they are historically air gapped. There's not necessarily a direct IP connection that you can establish to an airplane. But to your point, I mean, there's USB jacks all over the place. Remember about a year or two ago, there was a report where they actually found malware on the airplane systems, and they actually traced it back to a ramp attendant had charged his phone. It was an Android phone. The Android phone had malware on it, and then that jumped to the, again, air gap system, i.e. in this case, the airplane. So, I think that the traditional protections of just air gapping systems, may not be the panacea, and we can certainly talk a little bit more about that. So we've mentioned a couple of notable examples. It might be helpful if we just talk about a few others. So within critical infrastructure, what have been some of the key incidents lately, either that we've seen in the news and that might be relevant, or maybe that have gone underreported but are worth mentioning?
So I don't want to talk about a specific incident. I want to talk about actually some cool research. I'll give a shout out to the researcher I saw at Cycura a couple of years ago. It was an Italian gentleman who had done a bunch of research around industrial control systems and connectivity to the internet. And so what he had done is gone on Shodan, which is a search engine for identifying machines connected to the internet, essentially, and the services that are running on those machines. And using the filters on there, had done a global scan and had identified a number of different industrial routers that were facing the internet. And these industrial routers are usually part of PLC systems, programmable logic controllers, that control robots or control other elements of OT systems, right? You can use them for scheduling, you can use them for data inputs and for signaling and stuff like that, right? So these routers usually are the connectivity between those PLC systems and traditional IP networks. Those industrial routers are usually made by companies like Honeywell, Allen Bradley, Siemens. a whole bunch of others. There's a ton of them out there. And those should not be showing up on the internet. They should be internal to the organization. You do not want the internet having the ability to potentially get in there and address the robot or the system that is sitting behind these things. And the presentation I saw, his research, which, he had done a fair amount of research and also looked at the ability to kind of control these systems and manipulate and poison data, essentially. But during his research, he ran across over 18,000 of these things exposed to the internet. And what I'll tell you is that they don't get updated at the same frequency and regularity as a regular commercial consumer router, or more appropriately, a firewall that would face the internet that has a reduced attack surface. So these things end up with old libraries running on them, and they're sitting there exposed to the internet, and some attacker who happens to have some sort of working exploit for that particular version of BusyBox or whatever is facing the internet is going to roll by and pop this thing. And they may or may not do something malicious. They may just make it part of a botnet. They may just happen to hang on to it at some point later because they want to use it as a proxy. Or they might get in there and start tinkering. And who knows what that thing is connected to. There's a bunch of worst cases, and a lot of them are like, this thing is connected to some sort of manufacturing facility that makes medical equipment. And somebody goes in there and just starts messing with parameters. And suddenly you're not making a working heart valve anymore or something, like that's kind of worst case nightmare scenarios. But these kinds of systems are connected to auto manufacturing. And we did see a massive ransomware outbreak at Renault that shut them down for a period of time about 2 years ago. These things are connected in manufacturing facilities that make things like nuclear components, because the nuclear industry largely outsources a lot of the manufacturing of the components that go into their systems to specialized tool and die organizations and things like that. So there's a lot of potential risk that exists in those types of systems that we traditionally associate with operational technology and Scada ICS type environments. They are being exposed to the internet and to the kind of risks that we deal with in IT, and they're not equipped for it at all because they are OT systems, and they're usually supposed to be, back to your word, Ian, the panacea of an air gap is supposed to exist there. That's not the case. And I think Mo could probably tell a million stories about that too, from the work that he's doing at Armis. So.
Exposing routers to the internet. What if he's trying to work from home, man? Just access those routers from home.
Well, we saw that, right? I mean, that was the Florida water treatment facility where, by design, the supervisor had enabled remote access, and it turned out that somebody who wasn't the supervisor, again, identity issue, ding ding, but they had logged in, and I think I saw that the numbers were they increased the level of lye to the water from 100 parts per million to 11,000, right? Super caustic, super bad news bears for drinking water. But for, I guess, the point that I'm trying to make is that was a feature. Remote access was actually a feature within that water treatment facility. It's just that they got hijacked. Ian, the question, going back to the research with the 18,000 routers, were those accidentally online, or were they intentionally made online to Mo's point, for remote access?
Primarily, they're accidentally online. A lot of it comes from, again, manufacturing-centric companies, or sometimes large organizations, or sometimes research organizations. Having Class A, Class B IP spaces allocated, and publicly routable Class C IP spaces allocated, not realizing that when they connect this thing via the plug that goes into it, yes, it now talks to all the computers, perfect, that works, but that's a public IP address that you just connected this thing to. So it goes back to misconfiguration primarily. Not many of these should be exposed to the internet, and they create tremendous risk by being there because they don't have great security controls on them. It's good enough for inside of a manufacturing environment. I think if you're running the latest and greatest, maybe from Allen Bradley or Cisco might make it, some sort of industrial connectivity type device, you're probably going to be okay. But a lot of these things are going to be 10 years plus old, and haven't been updated since they were originally installed. So
it's funny because I was actually we were deploying in a university in their test lab, and I got to asking the person I was working with. I said, "Yeah, you know, is there a firewall or a proxy that we should be aware of?" He said, "No, I talked to my IT department, and there's no firewall." And I'm like, "Well, what do you mean?" And then we were talking about the actual Armis appliance. He's like, "Yeah, it's you should be able to access it." So I go from a Zoom session to my own working laptop across the other side of Canada, and I ping it and I remote in, and surely enough, it's exposed to the internet. And mind you, it's a test lab, right? But the point being is that we're just exposing all these things to the internet, and all you need is a foothold in. So when we're talking about, you know, those medical devices and what have you, it's not always that those medical devices directly get hacked, right? Somebody will come into the environment, get a foothold, and laterally move over and what have you. But then in the case of, you know, to your point of calling home or IP cameras, right? There was a recent hack with that affected Tesla, hospitals, prison systems, and what have you, you know, another two critical infrastructure components where the attackers were able to get access to, I think it was something like over 10,000 cameras. And again, you know, Ian, Plurilock, to your point, identity, right? It was administrative credentials that they got a hold of, and all of a sudden they have access to all these different organizations and government facilities.
So let me ask you guys both a question, because I think we in the security field see open and pervasive remote access as a bug. That is no bueno. I also think that we're making broad assumptions around a 10-year-old device. Like the three of us all will nod our heads saying that's a bad thing. That's not a good thing. But what is different about critical infrastructure? Why are these that they are, in the sense of why are they not updated more frequently? Why are they not secure by default? Like, what's different about either OT generically or critical infrastructure kind of more broadly that's different than the traditional paradigms of how we think about security in the commercial?
I'll jump in and probably mess this up, but when we think about information technology and information security, we think of the CIA triad, right? Confidentiality, integrity, availability. When you think about OT, particularly say in like power gen, first thing that they think about is safety. Second thing they think about is availability. Then you get to integrity, right? And confidentiality doesn't rank. Or it's such an afterthought into the way that the systems are designed. The systems are designed to be incredibly reliable, to have tremendous uptime, to be interoperable to a certain set of standards. And those standards are good standards when it comes to how this thing is designed to do its job, right? Be it a power switching relay, or be it, you know, something that does deploy chemicals at a certain ratio into the water system and measure that, you know, down to the millionth of a particle, right? Those are terrific standards, ISO standards that these are usually designed around, and other standards like NERC, CIP, and stuff like that. They are not designed to play nice or interface with traditional IT. They are meant to operate in their own self-contained world. You know, they usually interface with a Scada system, which let me totally screw up this acronym, a supervisory control and data acquisition system. Mo's nodding, I got it right. And then that's kind of where it starts and stops, right? It's a self-contained network of these devices, right? And they're all feeding data into these devices, and that data is relative to the operation, or relevant to the operation of whatever it is you're controlling. IT, we take for granted so much more connectivity, upgradability, less of a lifespan. These are all the things that are built into IT, right? Nothing's supposed to last 5 years in IT. It's supposed to be evergreened every 3 or 4, you know? Even, you know, Microsoft operating systems are like 10 years you're out. After 5, you're out of like major support, right? Like, and in OT systems, you're generally implementing something that's supposed to be in place and operational for somewhere between 10 to 15 years. And that's because the complexity of deploying these things, or integrating them into the system, or Upgrading them is tremendous. It's very costly. It usually has, if you're not starting from scratch, then the outage time and the planning around that is huge. And then as the system needs to be upgraded over time, these massive costs that have to be factored into the life cycle of these things. Most of what we do in IT is completely disposable compared to the cost of what some of these high-end, Siemens and Rockwell and Honeywell systems and the components that go into them are. Even little sensor units that are just taking some sort of air reading can cost, tens of thousands of dollars, depending on the complexity of what it's doing and the system it's built into. So you buy them for a long time. And the signaling protocols and the interconnectivity of them is not at the same level as IT. As I said, in a hospital, a lot of stuff probably runs on 2 wires and, just voltage signaling back and forth. And then the control system at the far end is reading that and is able to interpret the data from it. Is it performing properly? What's the reading I'm getting? Is it within normal parameters? That's kind of where we start and stop caring. In IT, we want all sorts of other data, and we want connectivity into it, and we want to be able to remote into it, and we want an API into it now, right? So that we can plug it into other stuff. So they're 2 very different worlds. And as we are trying to converge them, we are running up into that 10-year-old, this thing isn't compatible with anything. How do we extend the functionality of it so that we can support it, or so we can read data from it, so that we can think about securing it? That's my 10 cents on the matter. I'll let Mo chip in with his.
If I can just jump in, just to echo a few things that you said there, is that they're so purpose-built and proprietary, right? That they just, at the end of the day, don't know how to handle things that are outside of its normal operation. So a common example that I give is, an organization might just use a ping sweep of their entire IP space to say, show me all the devices that are on my network. But those ping sweeps, simple network protocol, can bring down your robotic arms. They can bring down your medical devices. They just simply don't know how to respond to these. And the other piece, again, just to echo what Ian was saying, is that these are so, IT has a specific amount of, let's say, resilience, right? If I'm working in finance, my laptop goes down, I'm going to unplug it right away. When it comes to the OT side of things, or ICS side of things, they always have to be on. Taking those down is, I'm going to say, it's not even an option, or it's a very, very last resort type of option where, hey, water system, it's going to dispense water to thousands of civilians that can get harmed and whatnot. So very purpose-built, and their uptime is a huge piece of their operations. Even the process to take them down and bring them back up, it just takes a ton of effort. So really, I think those are the 2 pieces that I see, is that, and the other point being, of course, that, Windows XP is still being used in a lot of these area gap segments and what have you. They're just not being upgraded. The other piece is, even if you wanted to upgrade, or if you wanted to install a patch, or you wanted to disable something like RDP that just came enabled by default, well, the vendor is going to be like, maybe we don't support it. Or how do you even test that? If you're in such a live environment that's real-time consequences, how do you even test disabling RDP on one of these things? You don't spend, $5 million to replicate that environment into a test environment. So,
So how do you test it, Mo?
Sorry, what was that?
So how do you test it?
How do you test it? Oh, Ian, you want to jump in on that?
I do. I really, really do. You don't. You don't test it. It's kind of one of the challenges that we have in working in this space is you can't get in there as a pen test company like us. Like there's no red team against the grid. You can get up to a certain point where you can say, yes, we were able to see this thing, we were able to talk to it, but you have to be very delicate, to Mo's point, before you even think about that. And then you don't get in there and start hammering on stuff the way that we take for granted with, cloud built native, beanstalk flexible, whatever it is we're testing, like it's not the same animal. If we knock this thing over, the impacts are huge. The closest thing I can think of is in New Brunswick, they were able to build a cyber testing range for IT OT systems. which is very cool. They obviously though can't replicate everybody's environment out there, but they have enough flexibility to set up a bit of a cyber range, and let people come in and test solutions and to assess whether or not there's going to be configuration and compatibility issues. And I know some of the universities and colleges also have like low-level environments for testing that kind of stuff. One of our customers has actually a decommissioned power substation, which is really cool to go in and do some testing and analysis in. And the vendor that helped basically helped outfit and fashion that power station, they do roll test equipment in there all the time. Much to our chagrin, we find that it's always in default configurations. So it's always the default passwords. It's always the, and so from a security standpoint, that's how it's designed to operate too, right? And they don't want you messing with that. In the production environments, a lot of that is true as well too. There was actually a pretty well documented Siemens problem a couple of years back where you could not change the default password on a power distribution system that they made. It would stop operating because the other components needed that default password in place. It was obviously hard coded somewhere, and it would break your ability to monitor and control the system.
That's a great point, actually. The hard coded passwords and the service accounts and all that. So even just looking at it from that angle, in order to even add security just from a very basic level of more secure passwords requires just understanding or even picking apart the system. Where is this used? And taking that a step back from even the testing, one of the things that I was wondering is, and feel like I'd love to hear you guys' comments on this, is that risk analysis piece, right? When you're talking about the organization, or even to your point, Ian, with air quality or humidity levels and whatnot affecting patient care, canceling operations and things like that, a lot of times, especially from an IT security risk perspective, will be, okay, client server architecture, we got to secure the client, secure the server, secure the network, and we're good to go. But when we're talking the business, it's a matter of what impacts patient care, what are all these factors, and now let's loop in the IT and the facilities team, again, converge those different teams, say, we have humidity or we have HVAC systems, do they have sensors, are they on the network, and what have you. I think that conversation really needs to evolve, and there is definitely that gap between facilities or what have you, risk management, and then the risk that the IT teams will manage. So
yeah, enterprise risk usually doesn't have much visibility into these types of things. I can certainly tell you that the university we were working with through that data breach was quite surprised to find out they could no longer turn the lights on in a number of facilities. Thankfully it's COVID time, so it's not impacting thousands of students, but it certainly impacted everybody who had to go on site and try and contain certain desktops that had to be taken off the network, that they had to go get flashlights to do it. So
nice.
Yeah.
So pack flashlights in your IR kit. Is that what I'm hearing?
Yeah. Yes, that is the hot new accessory for incident response in 2021.
so maybe branded flashlights for RSA 2022.
Yes.
Yeah, you heard it here first, kids. So we've talked a lot about kind of the industry, some of the problems, some of the differences, like what we might consider bugs versus features. What are you guys seeing in terms of recent engagements, recent deployments? What's currently out there in the field?
Yeah, I can jump in, and feel free to stop me at any point. There's a ton of different examples I can pick from, so I'll try and diversify this a bit into the different areas of critical infrastructure that we were, Armis was able to jump in and discover. So again, just talking bare bones asset inventory or asset enumeration, and what network are you on? If we take an airport, a passport kiosk found on the guest network, right? You have medical devices, over 250 for this massive US hospital, again, on the guest network. And that's simply the biomed team saying, it's just easier for me to connect to this unsecured guest network, or maybe the diabetes team is purchasing a glucometer and just, again, connecting it to that unsecured network, as opposed to me waiting for IT or opening a ticket or doing whatever I have to get this online. I got 50 other things to do. Let me just connect it and away you go. Again, this also takes a bit of education for the OT teams, for the hospital teams, or just in general, right? Another hospital, piece that Ian was mentioning was ransomware. when it comes down to something like COVID or something like an international thing where there's a lot of pressure globally, malicious actors, threat actors take advantage of that. So peak COVID times, hey, we're in the middle of a ransomware attack on a large hospital, literally as they're ramping up and scrambling to open emergency wards just for COVID patients. Threat actors saying, well, they don't got time to kind of counter us, so hey, pay up, right? I don't know if there's an ethics code amongst threat actors that say, you know what, it's COVID, let's take a break. But when we look at water treatment plants, one of the awkward points becomes when we go on a meeting and we'll say, hey, did you know about this? And there's that 2-second pause when the person's trying to figure out what's the best way to say, no, I didn't, especially if like there's a director or manager on the line. And we never want to make people look bad, of course, but you know, they have their air gap systems where we'll come in and say, well, why is there social media access coming from this water plant that you said should have absolutely no internet bound access? It should just be coming straight through to the data center or what have you, and that's where the data resides. In another case, it's a matter of, we were asked, hey, can you detect rogue access points? And when we dug a bit deeper, well, you know, what's behind that specific use case that you guys asked us about? Well, vendors came in. They connected a wireless NIC. They threw up a hotspot because they wanted to download, whether it's downloading, you know, drivers or packages or updates or what have you. But the fact that a vendor's now coming in and literally breaching all of the security protocols and all the things that you spent so much time developing and securing your devices, well, the vendor just comes in and says, well, I just need to get this set up. Here's the quickest way for me to do so. So that was a very, very interesting use case for us to understand and for us to help them out with, is literally even the people that service your equipment that you inherently trust to know what's best for those devices are actually putting those devices at risk itself.
Yeah.
And then, sorry, go ahead.
No, I remember a specific incident with a vendor bringing an infected laptop into an environment and it just wreaking havoc in that environment. Yeah, good times. And that vendor actually was doing a bunch of IT deployment work. So,
did they bill for that pen test or no?
No,
Yeah.
that was the free one that you get.
That's free? Got it. We're about
the free test of your IR services,
yeah.
right?
So we're about 20 minutes before the top of the hour. I see there's a couple of comments here in chat. If folks have either comments or questions, feel free to pop them in, and we're happy to address them. I'm curious, Mo, like going back to the data breach thing. So Canalys came out with their annual report, and I found this statistic even more surprising than usual. So more data breaches in 2020 than in the last 15 years combined. Yep. Was the headline. And despite a 10% increase in cyber spending year over year. I'm curious, when you're looking at data breaches, or even Ian, like when you guys are doing IR, incident response, do you have any sense, are these targets of opportunity because they just happen to be a hospital? Are the threat actors targeting hospitals specifically, or is it ambiguous when you're in there figuring it out?
Well, one thing that I want to raise right off the bat is it's not always threat actors from the outside targeting hospitals that results in data breaches. What's interesting, again, we were in a hospital and we found a bunch of things, but more specifically, there was an employee that was exfiltrating data, right? It was about 50 gigs over, you know, mounting a hard drive over RDP. Again, DLP security controls in place to accommodate for the USB, but not for mounting a hard drive. In another case, we were specifically asked saying, hey, there was a breach involved, and it's actually published, but I'm not going to necessarily drop the name, but a breach involved where the employee was literally just leaking over a long period of time. They had access to the servers, they pulled the patient information, and they were sending it out. So it's interesting to see that when we do go into these environments, yes, there's that aspect of outside actors trying to exfiltrate data, and you see that evolution with ransomware, right, where they'll exfil the data before they actually encrypt it. But on the flip side is we're also seeing that coming from the outside, from the inside going out.
Those are terrific points too. The insider threat is a huge risk, and most organizations don't know how to kind of control that or how to get their arms around that risk. To answer the question a slightly different way and talk about specific attack groups, I would say that they are today much more aware of what they are attacking. Mo just touched on the fact that they are exfiltrating data first. They are doing due diligence on these organizations. If you're publicly traded, they look you up and they're like, what was your revenue last year? Oh, it was $700 million. You can pay us, $7 million to get your data back, or we can just publish all your CFO's emails and your CEO's emails on this Tor site. Pick your poison. And so that level of analysis is now happening in these groups. It is moved away from, I would say, opportunistic hacking, still exists, but much less, more towards organized crime, but not in the traditional, mafia, yakuza kind of organized crime that we would think of. These are a new generation of organized crime groups. And it's not just ransomware that they're doing. There's all sorts of other interesting fraud that they're facilitating. If we circle it back to critical infrastructure, definitely hospitals are an interesting target because they will pay, usually, because the pain of not being able to operate is too high. And usually they have insurance in place. That's another interesting thing that these attack groups have been doing. They have been compromising the offices of the cyber insurance companies to find out who has insurance and what the policy is. And then they go and compromise that customer.
That's interesting. Wow. Okay.
It's a supply chain.
Bunch, aren't they?
Yeah. And that's been happening kind of at scale recently. So we're dealing with not necessarily a smarter attacker, but an attacker that's done more homework these days than it used to be super opportunistic. And
we're going from like a spray and pray, here's an email, to like 10 million email addresses, to much more targeted. Like, to your point, they're doing their homework, they're understanding the environment, they're looking at what's out there, and then they're crafting attacks specific to that organization or vertical, right?
Yeah, and the bigger now. And if you choose to try and negotiate and you come in at what they feel is an unreasonable number, and it seems insane to have this conversation, like, it's your data, like, you shouldn't have to pay that back. But if you come in at what they feel is an unreasonable number, they will just walk away. And that has been a big change that we've observed in the last 2 years. We used to be able to negotiate. We used to be able to get, from $500,000 down to here's 80K or something like that, because that's what the company can afford right now. Again, now they're looking up what your revenues are, or they have your books because they downloaded them, right? And they go through and find your finance sheets, and they're like, no, we know what's in your bank. Give us half, right? So that sucks.
Are you able to say, like, look, Bitcoin is too expensive, I can't even get the payment to you?
Here's a doggy fly at all?
There's actually, it's kind of a funny question, right? But there's a whole industry of brokers now around it. And the ransomware attackers themselves can refer you to a Bitcoin broker.
Oh, that's helpful.
It's super helpful.
Convenient.
You get a discount if you use their guy.
Yeah.
So the new age of affiliate marketing.
Yeah, it seriously is. It's wild. There's some questions in the chat if we want to speak to those.
Yeah, so I was just about to go there. So the point about poorly configured insecure products that can't be made secure, say because of hard-coded credentials, are there tips that you can provide about how to vet the vendor and what to do if the products in particular are borked? So how can we vet vendors, and how can we get vendors to do better?
Yeah, I'll start, and then I'll let Mo follow up if you don't mind, Mo. When I was in the hospital setting, that was a practice that we had to put in place because we had vendors coming in with all sorts of neat medical systems, and they were like, hey, we're going to roll this into your environment, and we're going to plug it into your network, and we're going to test it for 4 months, and then we're going to take it away, and then you guys decide if you buy it. And one of my first questions was, okay, have you ever pen tested this thing? Is it secure? Well, no, but it's FDA approved. Okay, and then what about the data that goes on it? Like, where does that go? Oh, well, we keep it. No, you don't. And it becomes an awkward conversation, but you as the owner of that data, you as the person responsible for the integrity of your network, have to stand your ground with your vendors, put a program in place that has a specific set of parameters that they have to adhere to, and enforce those rigorously, to the point where, I remember telling a vendor, yeah, you can bring it, yeah, you can hook it up, but you're going to leave the hard drives with me when you leave, and they're going to go in a shredder bin, and that's the end of their life. And they were super salty about that, because they were like, this thing costs a bunch of money to reconfigure. If you want to sell 10 of these to the hospital, then you're going to play ball, right? Yeah. The hard drives I know are just commercial hard drives. They cost $200. Yes, one of your technicians is going to have to reconfigure this thing, but I can't have my data go to the next hospital, and potentially somebody sees that Mrs. Smith has a heart condition and suddenly we have a data breach, right? So you have to build a program, and you have to enforce that program. That's part of the solution. That's not the technical part of it. I'll let Mo maybe speak to some of the stuff that he's seen in the field for how people are trying to tighten things up.
But they have military grade encryption, Ian. What are you worried about?
Military grade.
Yeah, absolutely. Ian's hit a number of points there, and we're seeing a lot more companies that are creating scorecards when it comes to these vendors, and the vendors themselves, like to Ian's point, they're having to hold themselves to a higher standard, right? It's gone are the days, or rather there's more pushback on the vendors to say, well, these security patches or these vulnerabilities, because again, they're becoming more mainstream. You have US CERT advisories that are coming out. It's like, well, how are we handling these? How are you guys handling these things? A lot of them are getting somewhat better, but the onus is still on the organizations to push back where possible, because they'll come in with the easiest implementation they can do, with whatever is easiest for them, right? The lowest cost, but highest income or highest revenue. So they'll continue to push that piece to an extent. And to Ian's point, FDA certified, yeah, that's great. But from a security perspective, from a perspective of protecting PHI, as an example, there's documents out there like MDS squared properties and files where you can actually pull those down and understand, okay, this Philips system, what are all the different auditing capabilities it has? What does it store PHI? Does it send it out anywhere? So a lot of different security and privacy guidelines and information contained in there. Now, when we're talking about the technical aspect, this is a bit more challenging. There is a lot of effort involved. It's no easy feat by any stretch of the imagination. When you're talking about a lot of these, when we're talking to our clients, when we're talking to hospitals, when we're talking to utility companies and things like that, it comes down to segregating the networks, right? You're talking about, Ian mentioned air gap networks. This is where you have your Scada environments and your OT environments and things like that. From a medical perspective, you're looking at, what do my medical devices really need to talk to? And let's scale it down to just that. So my bedside monitor are only going to talk to my central workstations. And what I'll give the vendors somewhat kudos to is that they're also recognizing this, and they are starting to carve out their own vendor managed networks. So if you look at the CareScapes and the Philips of the world and what have you, they will actually drop their own gateway. I'm not sure how much I agree about that, but they drop their own gateway. They keep their devices behind it, so there's ultra low latency. It's purpose-built network. So they're going even beyond a purpose-built device. Now it's a purpose-built network. It does create a blind spot for security teams, but hey, Armis gives you visibility. But yeah, there's a number of different things happening, and mostly it's happening at the network layer as opposed to the actual device level. Sorry guys, I had to throw that in there. Just
how big is the Armis tattoo that they put on you when you signed up? No, I think you nailed it, Mo. If your vendor can't do it for you, then you can look at doing it yourself, creating that segmentation and segregation through deploying some sort of firewall. And sometimes these can even be simple firewalls. So I've seen things as small as a Raspberry Pi deployed that is just using a TCP filtering stack. And it's only allowing connections on this port to this IP, these DNS requests to this specific IP address, and these protocols, and that's it, right? It's basically whitelisting at the network level using a small piece of hardware that you can easily maintain and keep up to date. And you can also isolate that hardware itself so that it basically is transparent, like nothing else can talk to it on the network. You can turn off the services and stuff like that. And it becomes, just a dumb appliance, but it serves a purpose of stopping other things from being able to communicate with those devices that have those hard-coded passwords that can't be changed and things like that. Can you do that, openly in an OT environment without testing first? Probably not. You're going to have to put some engineering thought into it and do some testing. But that is one way of solutioning for these things where you can't go and get additional security controls and layer them in.
And you raised a really good point, if I can just chime in there, is that the whitelist approach, right? As opposed to seeing what a device is doing and then blacklisting what you don't want to see, that list is going to go crazy, right? So I think that's an important piece to have. And I think that's where we're starting to see some verticals go with that network segmentation approach, is that they're flipping that around and they're seeing, what do my devices need to do? I'll enable these and inherently block everything else. So that's a really important approach to take as well.
So I think we've got just a few minutes remaining. Why don't we do this for the last question? Let's go around the room and let's go with one recommendation. We've kind of already switched to recommendations a little bit here in terms of tactics, but maybe one recommendation or piece of advice, and then where can folks, if they have additional questions, where can they find you online or find out more about Armis or more about Cycura? Go ahead, Mo.
So for my piece, it comes down to starting out with visibility, right? You can't secure what you don't know exists on the network. You got to understand your current state before you can take the next step, right? Before we can even talk security. Even if you look at any of the frameworks, NIST and what have you, it all starts with that asset inventory, software inventory, and even understanding your business critical systems. I would even argue take that one step higher. Don't only do that analysis about IT, but your entire organization, or bring the different folks to the table. But 100% from my perspective, it would be, we need to get visibility. How do you do that? There's network monitoring tools, there's telemetry tools, there's a number of different ways to accomplish that depending on the different verticals and tool sets or types of devices. But my whole thing is, I always push, do you even know what's on your network? How do you secure what you don't know exists?
Yeah. I'd just build on that, to be honest. Visibility is God in networks. That's what I've always said. Have that visibility, then the next thing is like, what does it touch and what touches it? And from there, how secure do we think it is? What's the what are the security controls that we think are effectively in place? And then have we ever tested it? And so that's the plug for what I do, but test the living hell out of it. If it's super critical, get somebody that actually, knows how to push on things in there and push on them. And then at that point, you have a risk profile. So what Mo's saying is, if you can't measure it, then you can't secure it. And what we're saying is, if you've never validated that it's secure, then you don't know. And then I'll bring it back around to Ian's realm as well too. Once you're aware of all these components, there's certainly the domain that they rule in, which is, how do I know who's using this goddamn thing, at any given time? I think the Florida water system one was wild. And the first thing out of my mouth when I saw that was like, man, Ian's system would have been amazing there, because it would have just cut the guy off in like 4 seconds.
Well, I mean, I wasn't going to do a shameless plug, but yeah, shameless plug. Like, if you need identity assurance to make sure it's the right person twiddling knobs or pushing buttons, absolutely, like, let us help you with that. But I think ultimately what we're talking about is identity visibility. I mean, this is the same point that you two are both making, which is, you need to know what you're securing. Our lens on this is that we want to make sure that it's the right people doing the right things. Sales at plurilock.com if we can help you with that. But ultimately, it just comes down to those fundamentals. So with that, I'd like to thank Mo. I'd like to thank my evil twin, Ian. I've had a lot of fun. I think we're definitely going to do some more of these. For folks who have follow-up questions, Mo, how can people reach you online?
Yeah, absolutely. I don't know. Are you going to provide, or my contact information is in the actual event information, or no?
It will be if you have a Twitter handle, or I think SoundCloud is what the kids are hyping these days, that you'd like to promote. Feel free to drop
Very
that.
nice. By all means, you can reach me on LinkedIn at Mohammad-Waqas, or even email me at Armis, Mohammad.Waqas@armis.com. Happy to have any follow-up discussions or any vertical specific questions you guys might have.
And Ian, where can people find you?
I'm only on tour. No, I'm on the usual places too. Cycura has a Twitter handle if you want to tweet at us. Otherwise, LinkedIn, just reach out to me directly or visit our website, which will be relaunching in 2 weeks with a fancy new one. So please ignore the old one. It sucks.
I look forward to. I am Ian L. Patterson. We'll see you all again.
Thanks, everybody.
Thanks, guys.